Hey guys, welcome back. Houston Math Prep here. In this third example of polynomial graphing, putting it all together, we're going to be graphing this polynomial p of x from factored form. If you haven't seen our previous videos on end behavior, turning points, and roots with their behavior, make sure you watch those first and come back here when you're ready. All right, we're going to start out by getting our degree. We know that we grab our degree by adding up all the powers of our factors. Okay, so our factors here, we have x minus 3, x plus 1, and x minus 6. So adding up their powers, that is 2 plus 3 plus 2, which is a degree of 7. So we have a degree of 7. We could have up to 7 roots, but we have 3 here. Next, let's jump into our lead coefficient. So lead coefficient, we're really only concerned with the sign. So I'm going to multiply all of my lead coefficients to see what my sign would be. So here I have a lead coefficient of 2. That's a positive. Times a positive x in here. Times a positive x in here. Times a positive x in here. So we have positive times positive times positive times positive, which would be a positive overall result. So for our end behavior, putting those two together, lead coefficient being positive tells me that on the right-hand side, I'm going to have up end behavior. Since I have an odd degree, I know that my end behavior needs to be opposite. So on the left-hand side, it's going to be down. So down, up, end behavior. Next, we're going to look at our roots and grab their behavior. So we're looking at factors. 2 is not a factor since it doesn't have any x's, so we're jumping right here into x minus 3. If we were to set that factor x minus 3 equal to 0, we would get a root of 3, 0. Our multiplicity is the exponent that root is raised to, so that would be 2. And then we grab our behavior from that. Even multiplicity gives touch behavior. Moving on to our next factor, our factor of x plus 1. If we were to set that equal to 0, we would have a root of negative 1, 0. Grabbing the power there, we have a multiplicity of 3. And that number is odd, so we are going to have cross behavior. Now moving on to our last factor, x minus 6. If we were to set that equal to 0, we would get a root of 6, 0. Its power there is 2. And 2, or even multiplicity, gives us, again, touch behavior. So putting all that information together, we're going to go ahead and start by graphing each one of our roots. So we have a root here at 3, 0. We have one at negative 1, 0. And then a final one at 6, 0. After you've got your roots graphed, you want to go ahead and plop the end behavior onto the furthest left and the furthest right. So since my furthest left is negative 1, I'm going to exit that one going down. So down from there. And my furthest right is positive 6, so I'm going to exit that one coming up. So now that I've got my end behavior, I want to use each root's individual behavior and just kind of logic to connect the rest. So here at negative 1, I have m equals 3 cross behavior. So I know that's going to kind of be that a little bit of a more flattened out type cross. So that's probably going to look something like that. Now to get back over to 3, since I'm increasing, the only thing I have to do is have a little turning point to come back. At 3, I have an even multiplicity, so I need to have that touch and bounce behavior. So rather than crossing through, I need to touch and bounce back up, and the only way to get back to 6 is again to have a turning point. That did give me touch behavior at 6. We want to verify that that is what we want. Over here at 6, we had even multiplicity, So that touch and bounce is correct. All right, guys, that does it for this last example video on polynomial graphing, putting it all together. Until next time, we'll catch you later.